Greetings, Royal Family, and welcome back to another fun African math play session. We're going to have fun playing a fun game called the African Math 10 frame game, and we are going to start by counting 1, 2, 3, 4, and we have 5. That's awesome. We have 5. We're going to draw out our ancient African numbers for 5. The ancient Egyptians used tally marks. This is our modern international number for 5, and we're going to draw out the quantity. 1, 2, 3, 4, 5. So we have 5. And now we have our counting toys to match the quantity. We use another symbol for 10. So we call our counters bits. We call them, some people call them ones. Some people call them units. But we call them bits. So instead of ones, we're going to make this a B for bits. And then we're going to have place over here. This is tens. This is where we put our tens. So for the African abacus, we're going to use the B's for green and our tens go here. Okay, so you see that symbol? The symbol here that represents an Nguni house of 10. The ancient Nguni houses look like this in ancient Africa, and it was embedded into the ancient Kemetic number system. So if you go look up ancient Nguni houses, you'll see Bantu and Nguni houses. You'll see this image, and it also represents a African arch. So if you go look up Nubian vault or African arch, you'll also understand that this symbol right here was used. It's a physics. It was used to displace the weight of the building so that the weight of the building would not collapse the doorways and window openings. And that's why this symbol was made into metal netter, for the reasons of reminding learners about the house of 10. And now that we have a 10 here, we would write the number 10. Ancient Egyptian numbers were not really positional. You can write the numbers any way you like. But our system here in the United States, so internationally, our international numbers require that you write the value in a specific order. So this is for place value. So there's the positional place value. So you have to position tens to the left of bits, so that we have 110 here, and we have 110 here, and then we have 5 bits here, and we have 1, 2, 3, 4, 5 bits here. Now, what's very important when you're doing a Bitric 10 system, because we have multiple place value systems here at Bitric. Bitric stands for the Benjamin Banneker Institute of Technology, Research, and Innovation, headquartered in Washington, D.C., which is where Benjamin Banneker surveyed our nation's capital and arguably even designed it. We use the Bitric system based off the ancient Egyptians' number system as well, and they had different units of measurement. Like the foot was used, they used the yard, they used body parts, they used the arm, they used the hand, and they had a unit of measure. They would group units of measure according to the body parts, because that made it easy for learners to understand. So here we have a hand. Okay, now I'm gonna go get some new beads. No, let me see. Let's use our yellow bits that we have. I'm gonna use the yellow beads right here, and I'm gonna put a bead in the hand. Now, can anyone guess what quantity the hand represents. Okay, if you said 5, then you are 100% correct. Now, the advantage of having a hand is it helps you quickly group a quantity. So if we have 1, 2, 3, 4, 5 beads, okay, we have 5 beads. And if we say, okay, now let me add 3 beads to it. Okay, so we have to first count in and disperse 5, 6, 7, 8, which is great. This is awesome. This is great for one-to-one correspondence. It's an advantage of the African abacus because early learners can learn how to count 1, 2, 3, 4, 5, 6, 7, 8, and it helps with arithmetic. Now notice I'm going to remove 2 of the beads. So we have 8, 7. Now we have 1, 2, 3, 4, 5, 6. The advantage of having the hand as a unit of measurement is because now, instead of having a fraction of 5 represent a quantity, we can have a group of 5 represent the quantity. So now we put the hand here and it represents 5.